Well, I've got 7 o'clock on my watch. So if it's okay with all of you, we'll go ahead and get started. I am very happy to be here. Well, that's 98% true, but something that's 100% true is that I'm happy that all of you are here. Today, we are going to do a short lesson on getting started with Data Classroom, graphing, and some statistics. Um, During registration, there were some people signed up for this that worked at the university. And just in case anybody here works at the university level, please know that there are two versions of the web app, one for K-12 and one for college and university level. The main difference between the two is that the college level has a few more statistical analysis options, particularly dealing with non-normal data, and also it has a bridge to R to help transfer stat skills to the R platform if needed. With that disclaimer out of the way, tonight I'm going to be using the K-12 version. Um, and we are going to be looking at a data set around cicada populations. And the main question we're going to be asking as we look at this data set, is there a difference in head width? Um, and we'll be asking that between sexes, latitudes, temperatures, and so on. I'm going to go ahead and start sharing my screen for you. And if at any time you are experiencing technical difficulties or have a question, just unmute your mic and shout out or raise your hand digitally, and I will try to keep an eye on those things. All right. So what you should see on my screen is the resource library. The resource library can be accessed from the dashboard. This is what your dashboard looks like. And there's a big banner up here that says resource library. We can click on it. In the resource library, there are a few different ways to search and navigate. You can search by subject, which is kind of your basic content areas like bio and bio-sci, math, physics, chemistry, etc. You can search via concepts, which are more stats focused. If you're looking for a particular data set that lends itself towards a certain stat concept, you can limit your searches to grade levels, and you can search the titles and text. So in the titles and text tonight, I'm going to type in cicada. And one of my big fears in these webinars is that I'm going to misspell cicada one day. But fortunately, not tonight. Tonight I got it right. And we'll see that cicada sex education pops up here. If you have a teacher account, you'll have two options for this. You'll have the open lesson plan, which is kind of an overview of how the lesson might be run in a classroom. And if you're a teacher or a student, you'll have the open data set. So tonight we'll click on open data set, and our first introduction to the Data Classroom platform is this table. This table should look familiar as it resembles closely Sheets or Excel. Across the top, you'll have all the variables that are included in this data set. For example, we'll have sex, head width, species group, annual temp, altitude, and latitude tonight. Every single column will be an individual variable, and every row will be an observation of that variable. You'll notice that when we load a data set from Data Classroom, that the variable types are already filled in for us. That would have to be done manually if you were to upload your own data. The main navigation that we're going to be using tonight are up here, these three tabs: table, graph, and assignment. We'll take a quick look at the assignment so that you can see the basic outline of how the assignments work for all of the lessons in Data Classroom. You'll have some background on the data set, in this case describing where the cicadas were, when they were observed, and when their head widths were measured. You'll have a detailed description of each of the variables in the data sets, and then finally an activity that helps students and teachers walk through the data set and kind of explore it, if they need a little more prompting or need an assignment to do so. I'm going to go back to our table view, and I'm going to click on graph here. This is kind of the main home of Data Classroom. And just like in the table view, we have our variables across the top, and now we have a little show button under each one. On, on the left-hand side is where our graphs are going to be displayed, and on the right-hand side is what I like to call the variable control panel. I'm going to click Add All Variables to this control panel, just so I don't have to click Show several times. And you're going to see all the variables now appear in the variable control panel, and Data Classroom selected 2. I don't know if it's at random, but I didn't make it select these 2. I'm going to deselect these just by clicking on the red X and Y, and instead I'm going to click under the sex variable. I want it to display on the Y, because this allows me to start visualizing what I have in this data set. So you can see that there's 171 populations of male cicadas that were observed and 170 female. I'm going to click Y, going down this list, just to kind of give myself and you a little introduction to this data set and see what it's all about. Head width, we can see in millimeters. We can see the variation of this. We can see the lowest one is just under 7. The largest head width was just over 9.5. We can see that there were 3 species of cicadas that were observed: 52 decula, Cassini, decim, and annual temps ranging from just under 8 degrees Celsius to 18, altitude and latitude. The reason I just walked through that is I just want to show you how easy it is for someone to kind of explore a data set on Data Classroom visually, without having to select ranges or enter in formulas or choose different displays. Our main question tonight, though, is there a difference between head widths of male and female cicadas? So I already have sex on the Y variable, on the Y axis. I'm going to click head width and put it on the X. And you're going to see, oh no, I get an error, because it's reminding me that best practice and common practice in statistics is to put the categorical variable on the x-axis. So to make that correction, I'll simply click the X for sex, and I'll get this nice scatter plot or dot plot between male and female head widths. And here's kind of where I start doing the eye test, right? It certainly looks to me like females might have larger heads than males. And I can do a couple of things to back this up. I can click on descriptive stats, and instead of median based, choose a mean based. Click on values, and here I'm going to get the means, the standard deviations, the errors for my male and female. But as we know, the eye test and even the means don't give us a p-value or a statistical analysis of how what the chance that this could be random variance is. So we're going to do our first statistical analysis tonight by going up and clicking on the bell and magnifying glass up at the top. DataClassroom is going to look at our graph that we have and say, we recommend that you run a t-test because you have two categorical values on the x-axis and one numeric on the y. We'll click calculate and say thank you, and it will give us a little pop-up saying what a t-test is, when it should be used, why it's used, and how it works. If we click calculate one more time, we get our statistical analysis. Anywhere that you see a camera icon in DataClassroom, that means that you can copy that data and take it to your favorite presentation platform and paste it in there, just like that. So we've done our first graph and our first statistical analysis. So I'm going to pause, and if you have any questions, please let me know.
I have a question.
Yes, Imani.
Do you does this DataClassroom interface with SciStarter?
I don't believe so. I don't know what SciStarter is, and I don't know what you mean by interface. So I'm going to say no right off the bat, but I'm happy to look into it. Is SciStarter a place to find data, or what is SciStarter?
SciStarter is citizen science projects for students.
I do. It's now ringing a bell. Thank you very much. So right now there's no direct interface, but we are working on. I'm not working on. The engineers are working on with the University of Tennessee actually on integrating in some manner the citizen science data sets with DataClassroom.
Thank you. That's fantastic to hear.
I believe they're in year 2 of 3 of that grant. Good question. Any others?
Okay, this might seem really basic.
It's just going to make me more embarrassed if I can't answer.
Degrees of freedom, t-score, p-value, interpretation of p.
Oh, let's go back.
What are the...
Oh man, I went to appearance. We don't want appearance here. We want statistical.
I see that your site will give you a recommendation to do a t-test. I mean, I use t-charts all the time, but I don't understand. I'm not familiar with the language t-test. So if you could help me with that. I mean, I have introduced data a lot, but not in this interactive way. I usually just present the data and let the students kind of, on the CDC site or on, some other site where it's kind of explained. And so I'm not really sure how to set up these values or scores.
Yep, no worries at all. In fact, a little later on, I'm going to take you through our interactive statistical analysis tool, which goes more in depth into what a t-test is, the math behind the t-test, and kind of visually represents what the math is doing when it's comparing two groups. But for now, yeah, the degrees of freedom, the statistical score, and the p-value are kind of the 3 categories that are mainly reported when someone is presenting a statistical analysis. and it gives us the 339 tells us how many groups, how many observations were in that statistical test. So, if we saw degrees of freedom of around 2, right, we'd say, oh, that's probably not a very strong statistical test. But the p-value, if we click on explain, we take this kind of, everybody's like, oh, if it's not 0.05, then it's not a good, statistical test. We got to keep the null hypothesis. But if we look here, we can see that the p-value really is just a line, a number line from 0 to 1. If a p-value is 1, we can say that the groups are not different because they're just random. It's just random chance. If a p-value is 0.5, well, that means it's a 50% chance it's random and a 50% chance it's not. And so we hope that with this number line and its ability to be...
So you know that the screen that you're sharing is just the doc that doesn't have like a number line or anything. It's just yeah, there we go. Okay, that looks a lot better.
Don't write any emails to
Thank
my
you.
boss, okay? All right. So let me go back because you didn't see how I got here at all. All right. So here we've run our hypothesis test using the t-test, and we don't really know what the interpretation of P means. So we click on explain, and here is where the student can drag this button along the p-value line and see what happens if they get a different p-value. If they ever let go of the button, it goes back to the p-value that was in their statistical test. But they can see, well, what if I got a 0.1? What if I got a 0.2? What if I got a 0.9? And they can see that really we're just analyzing what are the chances that this data or this difference is random. In this case, we're really confident that there's no randomness in this data. All right. But with this data set, there's a lot of more variables that we can explore. And drawing that data from the table, we can simply click along our variable control panel and explore some different questions. For example, species group. Let's put that on X. We'll keep the head width on Y. And we'll see that between species groups, there seems to be quite a difference in head width. But we might also want to know, well, what about male and females within those species groups? Well, we can do that by putting sex on the z-axis. And DataClassroom chooses red and blue to signify male and female. And we can see that in the visual test, it appears the females still have larger heads within the species groups, even though across species groups, the Cassini has a much smaller head width than the Decum. But if we want a clearer picture of that, we can click this button that says Group by Z, and it will pull out the females, separate the females and the males. And then again, we can look at the descriptive stats for each of those. We can see the mean based. We can look at box and whisker if we want to. And then we can run another statistical test simply by clicking on the bell icon again. Now you'll notice that DataClassroom, using the visualization of the graph, notice that it's recommending a different statistical test this time. It's recommending the two-way ANOVA because there's more than one categorical value on the X and Z, and there's a numeric on the Y. So once again, we'll just click calculate here. We'll get another pop-up about what is a two-way ANOVA, how's it work, when should we use it, and then we can click calculate, and it will run that test. Once again, we have our camera icon, so we can take these results and copy and paste them to our favorite presentation platform. We've had a few more people join, so I just want to pause after that statistical test and ask if there are any questions. If not, I'm going to spend a few moments to show a couple of different ways to graph and run statistical tests in DataClassroom, and we'll do that from the table view here. And let me clear my graph out. There we go. Then we'll go back to the table, and we'll see kind of this flow chart at the top. There's a preparation section that lets us know if there's any anomalies after we import our data. And then there's a visualization part, which is graphing. I'm going to click on that, and I'm going to open the graph wizard this time instead of just switching to the graph tab. Sometimes when we're graphing, we get stuck into one type of graph, and the graphing wizard can help us explore different options that might exist for our data. So we can look at proportions, changes over time. We can compare groups. We can look at relationships. This time I'm going to look at relationships. I'm interested maybe in the relationship between head width and temperature. So I'll go here and I'll say, well, let's do head width and let's do annual temp. You'll notice that both of these variables are numeric, which is needed for a relationship test. If I was to click on the sex variable, you'll see that I'll get a little error prompting me to choose a numeric. Click next. And it's giving me a couple options here, just a scatter plot or a scatter plot and a regression line. Well, that seems interesting. So let's click on the scatter plot and regression line. It asks me, would you like to have the graph set up for you? And I'm going to click yes, show me the steps. And I get a little pop-up here that tells me what I need to do in order to achieve this graph. Switch to graph. I can either do all, or I can click each one individually. Clear the existing graph. I guess I didn't need to do that. Select graph type, add variables to the graph, place variables on the appropriate axes, and add measurement or lines, and then done. This is just another way to kind of prompt students to think about the question that they're trying to answer with the data type that they have. Let's go back and do a statistical test using the interactive analysis. We'll do that with our head widths here. I'm going to save this. The statistical analysis likes to have it saved. So I'm going to Cicada sex demo, save. I'm going to go back to my table. And over in statistics, I'm going to choose interactive analysis. I need to choose my type of analysis. So I am going to choose a t-test. For this test, I can only have one IV. So I'm going to take away species group. There are unsaved changes. So I need to go back and click save again, and then come back, and then we'll analyze. Here it's going to prompt me to kind of write down the steps that I'm having here. So it's going to ask for a title, which is, we're just going to say a Cicada demo. We're going to enter the question here. It prompts us, it gives us a little hint at what our question might be. We're going to put question marks because we're not STAR students. All right, and then we're going to start our analysis. And so here's where you kind of get a little visual walkthrough of what a t-test is. It's going to give us a question up here, and then it's going to prompt us to guess what we think our p-value might be. I look at this and I think, well, there's probably some difference, but maybe not a lot. So I'm going to put it down here. I have some confidence that they are different. I'm going to click done and add notes, and you'll see that it's starting to fill out this little notebook based on my choices here. I'll click next. It's asking me to guess what the means are for each group. And so I'm going to do something like that. Click done, and you'll notice that it added my estimated mean here. And then it's going to say, well, why don't you calculate the means? And then it will visually calculate the means for me and then put in the actual means. I was pretty close on female, not too far off on males either. We're going to look at standard deviation now. So we're just trying to cover up 2/3 of the data. And so by dragging this shaded area, I will guess at the standard deviation, and then next we'll calculate the standard deviation. We're going to measure the difference between the groups. Visually, it's going to show what that means. And as I click through the next steps more quickly, you'll see that it goes into a little bit of detail about the math and the formulas and what those formulas are taking out of the data in order to come up with a p-value. Here we're counting the number of samples, and that gives us our degrees of freedom. The p shows you how the p-value is calculated and what the p-value is. If we want to see how it's derived from the t-score and the degrees of freedom, we can click on this and get a little pop-up that goes into more detail and gives us some exercises to see what the different types, how it might affect the p-value. And then finally, we come to our conclusion where we add our notes and we are done. So I have some options now to add a little bit of visual analysis to my notes. And then finally, I can download this as a PDF. I can save it as a Word doc and use it, you know, in whatever presentation the teacher most prefers. All right, so that is our graph wizard and the interactive statistical analysis. I'll pause for a minute and take any questions.
I have another question.
Sure.
Do you have any data sets that are more culturally relevant? I know when I spoke with Aaron before, he told me that there may be a data set that's based on driving while Black. I don't know if you have a data set like that, or if that was just an example he was giving me of how DataClassroom could be used. Do you have any data sets that are based on sociology or any economic trends?
I will go back to the resource library here, and I will clear out this, and I will just go down to social science here, and we will look at the data sets that are within that. You can see the driving while Black or brown data set is under the social science tag, as well as some other social science data sets that you can see.
Thank you so much. I appreciate it.
No worries. We currently have, let's see, we currently have 117 lessons with individual data sets, and we have someone who's always working on more. I think that the artwork came in for 5 more today, so those should be going up. And a lot of our data sets are customer driven. So a customer will ask, hey, I need a data set for this topic, and we'll make a lesson around that.
Oh, it's great that you can do that. And what is the timeline on the SciStarter project? Is that in a pilot stage right now?
So I am not involved in that grant work. So I don't want to overpromise, but I also don't want to underpromise. How would you mind just shooting me an email, and then I could loop Aaron in and we could get a real definitive answer? I just don't want to get anybody's hopes up and then be completely wrong.
Oh, no, that's okay. I will certainly do that. Just so you know, April is Citizen Science Month. So this is something we definitely want to use next year.
Understood. Understood.
Well, thank you for that. Like, interesting that we have 117 lessons to choose from. I know when I first discovered DataClassroom last year, I got in on one of your tutorials on Florence Nightingale and medical social science kind of questions, and just the lesson plan itself was really excellent. I have just a couple of technical questions. So when you showed us the graph of the temperature and head width, and you mentioned like, well, you can kind of arrange it to answer different kinds of questions. What if you were using temperature and head width, what would be an example of a question you would want that you would ask to get that kind of graph? I'm working right now with students on being able to ask good search questions so that they can get the evidence and the information that's applicable to their study, and trying to impress upon them that it's really important the question that you ask. You're not going to get the information that you want or need if you don't ask the right question. And so I'm just wondering if you could give an example of what an applicable question would be that would produce the temperature head width. And so I'm thinking like, so that's an annual temperature. It's not actually like the body temperatures of the particular individuals. And so are you trying to determine if the temperatures are higher, they result in higher or lower head widths? Or I'm just kind of wondering.
Yeah, I think, do annual temperatures affect the head widths of cicadas? is kind of maybe a question that I could start out with. And I could throw up annual temp, and then maybe put a regression line. And then I can look at this line and say, well, there seems to be some indication that warmer temperatures increase head width. I could say, well, does it do it differently between the sexes, between males and females? And I could put a regression line for females and a regression line for males. And I see that their slopes are really close together, and see that, yeah, while it looks like annual temp is affecting head width, it looks like it's affecting head width between males and females the same. And I could, also try that instead of annual temp. I could try that with altitude. And here we're going to see a much flatter line, which visually is telling us, it doesn't look like altitude is affecting head width. But if it is, it looks like it's affecting it a little more with the males than it is the females. And the same for latitude. I'll throw latitude down there. And see, the higher the latitude, the smaller the head width there.
Okay. So do you want to ask your question first and then find the data sets that correspond, or do you want to choose your data set and then just find a question that you can ask given the data sets that you have?
Yeah, a data scientist, and really any pure scientist, will tell you you've got to start with your question.
Got to start with your question.
You got to start with your question, and that question drives your observation and your data gathering. And your question is the holy grail and shall never be messed with until you start modeling and doing analysis. My PhD is in instructional tech, and the question I asked is, how do kids learn with their hands? And so I'm all about accessibility and learning and interesting and fun. So if there is ever a case where you have a data set and you see something visually that piques your interest and that gives you a question, I'm not going to fail you or fire you.
I like that. I said today that if there's not a game that exists for this lesson, then this lesson is not worth teaching. Like if we can't do something fun and interactive with it, then there's no reason to even be here. Okay, so one question that I came up with was, how do the populations of male and female differ? So this is like a moment, we're all watching this data eruption, and are we like I want my students to kind of be interested in this once in a quote lifetime event, and wondering if we are looking at like an abundance of females as opposed to males, or if these male and females are about equal in the species. So what if I was going to ask that question, I would definitely want to have species in those three species, and like you said, those should be on the x-axis, and then on the y-axis, or would I need three variables to ask that question?
Unfortunately, you were breaking up just a little bit. So you were interested in species groups, and how many observations?
The range, like the male-female population difference. So is it about 50% male, 50% female, or are we talking 20% male, 80% female? And does it differ between species?
That's a great question that I hadn't asked myself yet. But if we click on the male and female and put it on the X, and then we just put species group on the Y, we can see the difference between the observations on the two. So you see that in Deckham, they were both 83 populations. In Cassini, it was 62 and 61, and Decula 25 and 27.
Wow. Wow. So that like quickly you get like an actual like answer. That's like amazing.
I was so nervous about that.
And just to like visit the other person's question about, you know, driving while black and brown, you could put that in there and quickly find that, yes, you know, there is a difference in outcomes in traffic stops by race. I mean,
Before we
that
look,
would. So, thank you.
yeah, no worries, no worries. Well, we have 3 minutes left. If there are any other questions, a lot of times these webinars spur more questions, particularly after we click end. You're welcome to go on our website at dataclassroom.com, and you can book a half-hour session, one-on-one session with me. You're welcome to bring friends too, and we can dive into more in depth, like how to add students to classes, how to import your own data, and any other questions that you might have.
So I have a question.
Yes, Pat.
Can you add your own data to an existing data set?
Sure, you can. So in this table format here, this is all editable. Sort of, not to the functionality of Sheets, but you can insert a column to the right. You can insert rows above, insert a row above and below your selection, and add whatever data you would like.
Okay, thank you.
No worries, Allison. Yes, it takes me a couple of days to edit the video and then to upload it to the website. But when I do, it'll go under the past webinars tab. And I'll try to send out an email to all the registrants once I get it up. Yeah, no worries, no worries. Is there a time limit for a free account? So the free trials start at 30 days, and then you can request another 30 days. I'm the person that processes those requests, and I'll say yes to you. No worries, Meredith.
Nigel, isn't there like a free version of the account of access also that you can maintain?
Yes, yeah. There are free things that you can do on the account, mostly around graphing. Let me just open up. Oh, I think Chris asked a question that I missed. Can data be saved locally? So yes, even for me, when I collect data that I want to analyze the Data Classroom, I'm usually doing the collection in Google Sheets. And I guess that's not saved locally, but I could save it locally and then upload it to Data Classroom. I think that's what you're asking. No worries, no worries. And Chris, if I didn't answer your question, just feel free to shoot me an email and I'll try to understand it better and give you a better answer.
Oh, Nigel, what I was really wondering is if I had a data set that was created in the classroom, could I download that? I'm thinking for a future analysis in R or something like that.
Yeah, for sure. So in this table format, you'll see an ability to copy that table to the clipboard. So any table in Data Classroom can be copied and pasted to whatever Sheets or Excel that you like to use.
Thank you.